Welcome to CS5260 project part 2. My name is George. I will present the program assignment part 2. So before go over the part 2, let me just quickly go over what I have done for the part 1. So the main purpose of part 1 is to define the state quality functions. And for the part 1 state quality function, I have basically kind of three metrics. One is the arbor length per capita, cars per capita, and houses per capita. So this slide just go over what is arbor length per capita, which is a metric that measures amount of cultivable land available for agricultural purpose per person in a given country or region. And this metric can determine quality of a country, such as agricultural sustainability, as well as food security. Also, cars per capita, which is the measurement that quantifies the number of passenger cars registered or owned in a particular area per person. Provides insight into the prevalence of passenger vehicles within a population that can be used to access factors like transportation infrastructure, mobility pattern, as well as environmental impacts. Houses per capita, it's statistical measures that quantify the number of residential housing units, such as house or apartments, in a particular area, right? And also, I basically combine those metrics into a combine the state quality function. Basically I just sum them up and divide by the number of metrics, and then generate a percentage values. So that's pretty much what I have done in the part 1. In terms of state quality functions. Those functions are like major metrics to measure the quality of each country. It's important to know that while this indicator provide insight into a country's development, they should also be considered in conjunction with other social economics and as well as environmental factors. So this summary basically just provides a kind of summary for the state quality functions. Okay, and then let's just jump to the part 2. So there are three improvements that I have done for part of that in top of part 1. So first is converting from the static predefined operations to dynamic operations. So for this one, the part that I did for part 1 was actually not satisfying the requirement of the project, where I predefine the operation and then have my code to to basically schedule the predefined operations and then come to a state for each country. In terms of that, what I have improved is I use dynamic operations, meaning I just give a level like a depth value, integer value, and then having a search algorithm to let it figure out, okay, what kind of operation is the best optimized operation that I can have for each country. So that's one of the kind of a big improvement that I have done for part 2. So second one is the enhance for the mathematical equation for state quality functions. Which is where I combine those metrics into one single function that will return a percentage value. Of course, the third one is adding work manager and work scheduler to simulate the AI agent to generate operations based on country-specific resource. So for part 2 extension approach, I choose to gamify the simulation, to gamify the to basically gamify the simulation, right? For for project part 2. So what I did is I introduced really there are really two components that I introduced. One is a work manager, another is a work scheduler. So what is a work manager, right? So you can just think about it. And work manager is like a kind of the god of the work, right? Where it has a centralized blackboard that manages the whole world, like kind of a god view of the entire world, of course, the view for other countries. Constantly sync with countries for status. So basically, all the countries will sync with the work manager constantly with the country specific status, resource state, state quality function state, everything, like every metrics. Of course, AI based agent that could, the work manager is also an AI based agent that could gradually improve each country's state quality. Right? So that's work manager. What is a work scheduler? Right? So as the name indicates, the scheduler is nothing but a centralized scheduler that schedules operations to all countries. So the final output of the work manager is the list of operations, and then the work scheduler just kind of implement the operations. So basically, that's kind of the extension approach that I choose for project part 2. So this is high level overview of the architecture. As you can see on the left side, there are in this example there are two countries, country 1 and country 2. So country 1 and country 2 will, like I said, periodically sync the status with work manager. What it does really does is it's kind of a one directional sync. That the countries, all the countries send the status to the work manager, right? And then work manager will perform a search algorithm. So there are a lot of like pipeline in the work manager. And the work manager output a. So in the next in the next slide I'm gonna go over, what exactly how exactly work manager works, right? But with this diagram, the input of the work manager is like what I call is telemetry, basically all the metrics, and the output is the operation, right? So the work manager will pass the operation to a scheduler. Scheduler will schedule will basically do the schedule work based on the operation that actually received from work manager, and then apply it to the countries, right? And after that, country will again sync with work manager. What is my latest status or state after I was scheduled by the scheduler? So this is kind of a loop, like an ecosystem loop that always keep this as a better as a better word, right? Okay, so here's a work manager. So first of all, country status, sync with work manager. The first pipeline is the normalization, the basic normalization pipeline, right? So what that means is, I have all the raw data. The first step I have to figure out, how do I, normalize the data, so that all the downstream pipeline can process with kind of a same format of data, like same kind of a data structure. And this is also a very generic, AI machine learning pipeline. So on the second pipeline, is the feature extraction pipeline. What we call it FAX, feature extraction. So what it does is, it will extract the features of the data. Right? For example, like this country, has number of cars, number of resource. That's all considered to be features. Right? And then once the feature was tracked, there comes the learning and the searching pipeline. Right? It will basically implement all the like searching algorithm, modeling, and then what it outputs is a decision, and we'll go to decision pipeline. So basically, decision pipeline will have the output of the learning pipeline, and then be able to generate all the operations. And of course, after the operation has been generated, it will just pass to the scheduler. Right? So the most probably the most I guess most important thing that what we learn in this class that can be applied to the pipeline is the the learning searching pipeline. So just like project part number one, project part one. What I have implemented is basically like a the breadth first search tree that all the like the root node will be the initial country status, with the BFCS tree, it just search all the nodes it visit as well as the neighboring nodes until it reach a certain level that you previously pass into, or it will just search to the like the end of the nodes. Yeah. So yeah, so that's pretty much all I have done for the part two. And thanks for watching.